F20. So you worked through the other parts of that one? Because that one kind of built on each other, right?
Mm-hmm.
Does anybody have any other questions on other parts of that one? Okay, so we got that single demand curve, 100 minus Q, and each one has constant marginal and average total cost of $5. Okay, I can't remember how much of the. Here we go. All right, so with the Stackelberg case, we take who's the first mover? A is. So we want to solve for B's reaction function, which should have been the same as the Cournot model before, correct?
Mm-hmm.
Okay, you okay with that part?
Yeah.
So first step, finding that. Assuming that A is the first mover, the inverse demand function faced by firm A is this. So we're going to substitute B's reaction function into the whole inverse demand curve. Are you okay with that? So that's the part, that's kind of I guess the key difference between the Stackelberg and the Cournot is that instead of solving for its reaction function acting independently, it's got the luxury of using the entire inverse demand. Are you okay with that step, or is there a question there? Okay. And then from that new function, we do the same trick we did with Cournot, really. That's the only difference, because now we're going to find the marginal revenue, equate that equal to marginal cost, and find that the quantity is 4750. Shove that back into B's function. And the reason we need to do that is to find the market quantity to find the price. So we had to find both A and B's optimal quantity and then shove it into the market demand function to find 28.75 as the market price. Does that help, just walking through it, or was there something above?
Well, we have a format like this on the test where we have to solve through all four of them.
I haven't decided. I haven't done the test yet. So, do you like it that way?
Yeah, kind of. I just been taking more practice for my ability.
Yeah, kind of working through this format, kind of. That's why it's set up that way. As you can see, they're related to each other. So a lot of the concepts are similar. Because with the Cournot, you just do that for both firms and then set them equal to each other. Does that help, Taylor?
Mm-hmm.
Okay. Any other ones?
I don't know, but it's like 3 pages of homework, so
Good. It worked. All right, let me collect those. I'll give you something to review. So I guess while I'm waiting for Blake here, we got, or not Blake, sorry. Game theory stuff is what we're hitting today, chapter 12. So you can go ahead and start working on that first problem. We got 2 grocery stores. Let's see, I gave you one.
When was the learning curve due?
This morning at 9. We had them both. Were you here Friday or were you gone?
I was from one.
Okay. If you guys miss a day, make
Right.
sure you, I sent you an email too, actually, Colby.
Yeah, I was.
Okay. But in general, you guys need to come to me if you miss a day to see what was out there. All right. So, a couple grocery stores in a small city considering ways to update their stores. Each store can build a new store, remodel its existing store, or leave the store in its current location. The game is below. Food for you, payoffs are listed before the comma, and grocery mats after. Payoffs are listed as store's annual profits in thousands. Are there any dominant strategies for either the food for you or grocery mart? So take a look, back to kind of eyeball training here. I'm going to rewrite the matrix on the board and actually pull this a little closer now. So, dominant strategies. You see any? Okay, so build, remodel, leave. Build, remodel, leave, grocery mart, food for you, 200, 200, 300, 400, 400, 150, 400, 300, 450, 50. A little different. Colby, I don't know if you did them, but we never did a 3x3 in principles class. For had me. So this is a little new, so we can have multiple choices. So eyeball training exercises. Is there a dominant strategy? One strategy that leaves the agent better off no matter what? What'd you find? Grocery mart doing a what? A remodel. So when we think about grocery mart, we want to kind of put our grocery mart goggles on and kind of almost ignore these payoffs. So you kind of want to hone in on the second column of payoffs. And then grocery mart's choices are changing from column to column. So 400 is greater than 150 and 250, so that's a good domination. 450 is greater than 300 and 175. 350 is greater than 300 and 300. So yeah, we got a dominant strategy. So grocery mart goes there. Did Food You More have no dominant strategies? Didn't see any? So as soon as we find something, so now, again, we're choosing rows now. First payoff. So this one dominates. This one dominates. Oops, this one doesn't. So because 350 is greater than 300 is actually dominated at that point. Okay. So are there any dominated strategy? So a dominated strategy is one that is for sure a loser no matter what. So it's the one that's for sure a loser no matter what. Yeah.
But, on the, when food for you leaves store as is. No, yeah. And they're both 300, grocery store and the store as is are both 300,
So which one's dominated?
Well,
Leave as is for who?
grocery mart, I don't know, because, for grocery mart, or when food for you leaves the store as is,
Yeah.
the payoff for grocery mart is 300 on both buildings.
Okay, now when we check for dominant or dominated, ignore the other firm. See, that has nothing to do with the other firm. Other than,
What?
oh, you're not looking at the other firm. Okay, sorry.
The bottom two corners,
Okay.
both are 300 for grocery mart.
Oh, okay.
So they're both,
That comes
like, they
down to
both
that.
have a higher payoff, but is that technically dominated?
Okay.
They're in
So
different-
let's work through here. So leave as is for food you more, right?
Yeah.
So we got 150 is their payoff, 175. So 150 is dominated by both of these.
Right.
175 is dominated by both of these. And then we've got
I'm looking at grocery marts,
grocery marts.
leave store.
Leave store as is. Now we're on the columns. Okay. So 200, 400 dominated, right? Okay.
Yeah.
And then this is the one you got problems with.
Yeah. Is that technically dominated? Because they're in different choices.
Yeah. What do you think?
I think they're not dominated.
Not dominated if it's a tie like that? So let's look at read me off the definition we gave last time for dominated.
Losing strategy for a variety regardless of who the opponents.
Okay, losing strategy, regardless. So is it a losing strategy regardless?
But it says regardless of the other opponent's, strategies, then you have to take in consideration of the other one. Like, I don't understand why we only look at their column if the definition is same in comparison.
So think about it this way. Is it safe to eliminate that strategy? Is kind of one way to think about it. I mean, is it safe to eliminate it if it's a tie like that? In other words, are we potentially committing an error by eliminating it? Might be another way to think about it. So if we got rid of this one, if we got rid of this one, leave it as is, are we potentially in a worse situation?
No.
No. So it's dominated. So that is one area where it gets a little slippery. So dominant strategy means it's for sure a winner no matter what. And the other way, we haven't made ourselves worse off. It's still dominated given the other information. All right, so dominated is here. So Fujimore, by the way, knows that that's dominated for Grocery Mart as well as Grocery Mart. So that kind of brings us to Nash equilibrium, part C.
Was the one preferred food for you?
Not dominated. So with Grocery Mart, does that change things if we have a dominated strategy? Does that change the dominant? Kind of taking in combo dominated and dominant. So if this one's dominated, does that change the tune for Grocery Mart?
So dominant was here, right? So it was already dominant on each one of these. So would that have changed it possibly? No. So we're okay there. So this is still dominant. So we got a dominated, a dominant. And so what about Nash equilibrium? What's our thoughts with Nash? What needs to be true for something to be a Nash equilibrium? Neither one of them wants to change. Remodel, remodel. So if we go remodel, remodel, would food want to change? No, because 450 is greater than 300 and 175. We already know that grocery mart wouldn't. So Nash equilibrium.
So the dominant strategy was grocery mart remodel.
Yes.
And the dominated strategy was grocery mart.
Right. So in terms of these questions, I guess, part A, dominant, grocery mart has dominant strategy of remodel. Grocery mart also has dominated strategy of leave it as is. And we've got a Nash at RR. So R, and notice one thing that we need to do a little differently than principles class, I was a little more lenient on that. You typically do not put the payoffs in, you put the strategies. And the reason we do that is that, especially if you get into sequential games where you might be going, first I'm going to go left, then I'm going to choose A, then I'm going to choose right, and now I'm going to choose X. That's your strategy set. Boom, 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 boom. And so we don't put the payoffs. At the end of the day, that strategy set might give you $150, but we don't just put the payoff as the strategy. So the Nash equilibrium strategy here is RR. Now, go ahead.
I don't get how you're finding the dominant and dominated, because the way you found the grocery mart, I was looking at it for you, and it just didn't get it.
Okay. So let me just explain the dominant one. So grocery mart has the second payoff. So kind of put blinders on to all of the first payoffs. Just try to visualize this whole matrix. What's that? You can do the circle thing on your paper. Sometimes you might not have the luxury of a circle thing on your computer program, but if we got our training wheels on, or you can always write it out on a side paper too, if that helps. So there is grocery mart. So there's their choices. And so this is, if we look at this payoff, this one's bigger than this one and this one. This one's bigger than this one and this one. This one's bigger than this one and this one. So no matter what, that gives the best payoff.
Okay, so as long as it's bigger than
Than everything. Yep. It's a choice that leaves you better off no matter what the other person chooses. So if the flip side to look at it this way is if food chooses to, what's the B stand for again? Build?
Yeah.
If food store builds, this is the best payoff. If food store chooses remodel, this is the best payoff. If food store leaves, this is the best choice. So no matter what food store does, remodeling is the best choice for grocery mart.
So looking at the food for you, you would look at, obviously the left column, you would look up and down.
That's right, because they're choosing this. So and then the process that we went through last time, were you here on Friday?
Yes.
Okay. Because I wrote it out in longhand, you can go, if, I'll just do one, if G chooses to build, then food more should choose what? So if G chooses here, then the best choice for food you more is is that what it is? Food for you is to remodel. Right? Out of that choices. If, I'm going to do just one of these here. If G chooses to remodel, then food you more should do what? Still remodel, because 450 is bigger than both of them. And if grocery store, grocery something or other, she's gonna blow. Huh. No idea, nothing seems to be going crazy. Alright, we'll just tolerate that for today and call it in if it keeps doing it. Kinda irritating, but yeah, I guess we're not really using it anymore. It's almost like it's on battery power. Well, we'll see if that shuts it up. Okay, so if they choose, if Grocery Mart chooses to leave, then what should they do? Bill. And therefore, since we got a different answer here, no dominant strategy. And then you could go through to do that for each one if, well, no, that's it. That pretty much rules it out. There's not a choice that for sure leaves it better off. The shortcut method is just to look at the payoffs. That's kind of the shortcut to say, oh, there's not a choice that is bigger no matter what. Yeah. You think, oh yeah, there we go. That should do it. I saw the battery thing was kicked on. That's what it was. You're right. Good call. Good eye. Good eye. Okay. So on the Nash equilibrium, are there any other ones? And if there are, where would they be? You guys remember that from principles class? There was one little trick that I wanted to remind you of. They'd be on the diagonal. That's right. So if you go on the diagonal, the only place, so basically there's no way they could be here or here. So you can kind of start to check, would food for you like to switch? No, because 400 is greater than 350. Would this guy like to switch? Yes. So that's not a Nash. And then you could kind of check each one that way. So is it a best response for both is all that you want to check for Nash. Would either one like to change their mind? So yes, that one wants to change. You can check all the diagonals. This one would like to change. As soon as somebody wants to change.
Why is that? Why can Allen be the diagonals?
If we found a Nash and we didn't screw up, by the way, but assuming we really found a Nash and we're comfortable that that's really a Nash, then in order for this to be a Nash, it wouldn't make sense because you'd have to switch. Yep, that's why. So it has to be on the diagonal. Okay, so remember that little trick. Anything else? There's no more Nash for this one. That's right. And when you guys read the chapter, they do a little checkbox method that kind of walks you through the logic of, is this the best response for food you more? So this is the best response. And is this the best response for grocery mart? Yes, it's the best response. So it's got two checks which make it a Nash equilibrium. So that's the check mark method. You'll see that they work through that. Down here, let's see, I want one where it's the best response for somebody.
What about if you have the same number?
Yeah, so this one is the best response for Fujimore, right? So it would get a check mark because 400 is greater than both of these. But it's not a best response for Grocery Mart. So you kind of go through and ask yourself, is it the best response for me in this column? And then if it ends up being the best response for both parties, then that's a Nash equilibrium. That's the check mark method.
So there's 3 options on this one, but if there are only 2 options, if there's a dominant strategy, there has to be a dominated strategy, right?
No, I don't think so. Let's see, this was dominated, right?
Yeah.
So if I change this to 310, it's not dominated anymore.
Right, on a 3, but if it was just 2 choices.
On a 2, yes, you're probably right. Yeah, I think if there's 2, then it would be. Yeah, the one that's, I see what you're saying. If you've got a dominant, then you have a dominated. That's correct, in a 2 by 2. That makes sense, yeah. Good point. Anything else? Page 2. We've got some motorcycle. Honda and Suzuki are considering offering 10-year full coverage warranties for their new motorcycles. Although the warranties are expensive to offer, it could be disastrous for one firm if it does not offer a warranty while its competitor does. Let's assume the payoffs for the firms are as follows. Profits are in millions, with Honda's profits in red, which ours is black and white. So before the comma, Suzuki is after. So if the game is played once, what will the outcome be? What is the outcome? So take a look at that. See if you can solve the game with a one-shot game. We have 2 competitors, so we could assume it's a non-cooperative deal. I'll just replicate it here. All right. If the game's played only once, what is the outcome? To offer, why? It's a Nash, okay? Is there a dominant strategy? So as you start training yourself here, I like to start with the one to the left. I'll just tell you how I look at this. And then I focus in on only the things, the first number, 20, 120, 10, 150. 20 is greater than 10, 120 is greater than 50, dominant strategy. So right away, Honda's got a dominant strategy of offering. Suzuki, focusing on the columns, 20 is greater than 10, 120 is greater than 50, boom, boom. We got a dominant strategy of offer for both. Is it a Nash? Well, it's going to be a Nash, but let's just kind of pretend that we didn't know that. But I would always start off with dominant strategies. And as Taylor pointed out, if that's dominant, then there's dominated strategy is the other one. Is it the best response? So is this the best response for Suzuki? Or for Honda? Yes, 20 is greater than 10. Is that the best response? Yes, there's the check mark. That's a Nash equilibrium. The only other Nash would be down here. Would Honda like to change? Yes, so it's not a Nash. So this is not the best response. This is not the best response. Now, is that's it for the best responses since they're both dominant. All right, suppose the game is repeated 3 times. Will the outcome change from your answer in A? So if we do it 3 times,
So one was don't offer and don't offer not.
Excuse me?
Don't offer and don't offer was
Not a Nash. So a Nash equilibrium is 50 is don't offering the best response for Honda, taking as given that Suzuki's not offering. Is that the best response, or would Honda rather switch their answer? They'd like to switch because 120 is greater than 50. So it's not a Nash. Okay, so Taylor, you say yes if we play at 3 periods?
Yeah.
That's different? Why?
Because I think that if they play it again, either one or both of them is gonna switch to don't offer.
Okay.
So if one of them switches, because there's a higher payoff, I don't offer, assuming that the other one's not going to switch.
Okay, so,
I think on the third one, they're gonna end up with both don't offer.
all right, so the third, you'd agree, is 3 periods. You're thinking that on the third, we have don't. Basically, they'll play the Nash there, correct? So, knowing that, what is the best response? What's the best thing to do in period 2? Is kind of the way to maybe try to think about this one. So first of all, are you guys comfortable that if you pay 3 times, there's both have incentive to screw the other on the last period? Right? I'm sorry, I had this up. Did you say this or did you say offer?
I said don't.
Oh, you said don't. Okay, well then we need to talk more. So why do you say don't?
Well, I thought
I had my O's and my D's messed around, so I was thinking you were arguing for the O.
I thought that it was because it's a higher payoff, but then when I thought about it again, that once they get there, they'll both have incentive to screw each other.
That's the story,
So then
yes.
they'll go back to the Nash.
Right. So if they both are thinking, oh well, maybe if I'll test the waters, so to speak, in period 1 and not do it, and then if I get screwed or not, we'll see and kind of play. But for sure on the last period, if they both recognize that they're going to screw each other over and offer, which doesn't sound bad, the consumers get the warranty, I guess, but then what does that conclusion bring to the optimal way to play the second period? So it's like we're playing the first time, the second time, and the third time. And we're kind of like, okay, well, both parties are going to think they're going to do this in the second period. So then how do you rationalize how to play the second period, knowing that that's going to be the way the third period's played? They're both going to cheat again. Yeah. So that's using backwards induction. So if you know that that's going to happen, it's kind of unraveling back to the first period that the optimal way to play this game is to play Nash the whole time. That's the logic of it. The rationale is that if you think that's the way the last period's going to play, then the new last period is the next period over. And then you go through that same rational process, you're like, oh, they're both going to screw each other over. So even if we're playing 99 times, the thought would be that it would collapse down to the Nash equilibrium.
So because they think Bill is gonna cheat them, they're gonna offer it? Like it's
Right.
more than offer?
That they're both, that,
They're both, and then the other one's not going to, which in turn makes them both have an offer.
yeah. So they both kind of look at each other and say, you know, if we both didn't offer for all 3 periods, we'd both be better off. But then it's like, oh, okay, I see, but my incentive is here to screw them on the 3rd period. And then I capture the 120 if I'm Honda. But Suzuki's thinking the same thing. And then, oh, if he's thinking that I'm thinking that I'm going to do that, then the real last period is now this period. And then you go through the whole rationalization process, and the incentives are set up to do the same darn thing. And so using backward induction is kind of the thing that we're doing, which we're going to continue to do with games. Backward induction makes offer the best response for all 3 periods. Now that all gets more messy now if we play a repeated game indefinitely, which is part C, which might come back now to what you're thinking. So part C is that we're going to play indefinitely. There is no ending period. All right, and there's a little bit more. We're already here. So now suppose the game is infinitely repeated, and Suzuki and Honda have formed an agreement not to offer warranties to their customers. Each firm plans to use the Grimm trigger strategy to encourage compliance with the agreement. At what level of D would Honda be indifferent about keeping the agreement versus cheating on it? All right, so this one takes a little more explanation. So Honda's expected payoff from cheating and offering a warranty would be the 120 from the first period. And 20 million for each period after that, because Suzuki would also start offering warranties. So the trigger strategy is, once you've screwed me over, then I'm not going to cooperate for the rest of the game. So that's the trigger strategy. Let me, and that's the Grimm trigger, which let me get you the textbook definition here. So we can have that to go with. So the Grimm trigger strategy cooperative play. It's a strategy in which cooperative play ends permanently. That's the Grimm part. Ends permanently when one player cheats. And then it's not asked in this problem, but I also want you to write down the tit for tat strategy. Anybody got a guess of what tit for tat means? Maybe you've used that. Tit for tat. So the Grimm trigger strategy is, you screw me, I'm screwing you forever to your grave. Because this game's played indefinitely, right? Tit for tat's a little bit different than that. So tit for tat, what does that mean?
Is it like, you screw me, I screw you, and then we go back to the agreement?
Possibly, it's like that. It is definitely, you screw me, I'll screw you. But then if you treat me good, I'll treat you good back. Tit for tat. So I'm always mimicking what you chose last period, tit for tat. So tit for tat is a strategy where a player mimics opponent's last period's action. So you're not screwing them. If you get screwed over, you're not necessarily committing to forever. So basically, in screwed leads to screwed, cooperate leads to cooperate. So whatever you did last period, I'm going to do back to you. But at least it leaves a chance for the game to come back together. All right, so with this grim strategy, we're going to introduce some expected values, is what this little D part came in. So each player can kind of calculate their expected values. So as economists normally do, if the expected payoff from cheating is better than the expected payoff from cooperating, what should you do? Cheat, right? That's our rational person. We're stripping out all emotions and everything, right? It's just a business decision. If it's better to cheat than to not cheat, then I'm going to cheat. If it's better to not cheat, I'm going to not cheat. So here we got a game being played forever, though. And so that makes it a little bit more difficult. So similar to what we did here, if it makes sense to cheat in the 5th period, it would make more sense to cheat in the 1st period. It would kind of collapse down. So we just need to focus in on the 1st period's cheating. So the expected payoff from cheating is equal to 120 plus D times 20 plus D squared times 20 plus D cubed times 20. And I'll explain that in a second. And then this goes on forever. Dot, 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 dot. So what is the 20? So we're dealing with time, right? We're playing this a number of rounds. I'm looking at the expected payoff from cheating. If I cheat on the agreement and I offer a warranty to screw over Suzuki, I get 120. What's this, do you think? What do you speculate this little chunk is? It's got the 20 in there, notice. And then it's got this factor of D. So first of all, what's 20? What you're going to go back to. So that's going to be your payoff. If the other opponent's playing a grim trigger strategy, you're screwed forever. So you're going to get 1 period's payoff of 20 by screwing them, but then they're going to screw you forever, and you're going to end up choosing this is going to be your best response. So your best deal here is you're going to get 20. So in time period 1, you get 120. In time period 2, you get 120 in time period 1 today, and next time period you get 20. But is $20 worth $20 today? Is $20 tomorrow worth the same as $20 today? I'm drawing on old classes here. If I gave you a choice of, I'll give you $20 today, or if you want to, you can have $20 a year from now. Which one would you pick? 20 today. If I gave you a choice of $20 3 years from now or $20 4 years from now, which would you pick? 3, right? Time value of money says that money sooner is preferred to money later. Now there is a number though that I could find by quizzing you and say, well, how about $20 3 years from now, but 25 4 years from now, or 26, or 43, or 100? You know, what would I need to give you to offset that extra year that you're delaying it? So that's this discount factor D. And so D is kind of our in general, a discount factor. All right, so so by the way, this was Honda's. It's going to be the same for the other one, but Honda's expected payoff from cheating is 120. So what if they don't cheat? What if they don't cheat? If Honda doesn't cheat forever and Suzuki's playing the grim trigger strategy? What is Honda's payoff? 50. So we got 50 plus 50 times D. Whatever that D is, we're playing the same game, that it's D times 50 plus D squared. By the way, the squaring part just comes up from discounting type stuff. Plus dot, dot, dot. So we get 50 forever, as long as we don't cheat. Or if we're going to cheat, it's always better to cheat in the first time period, and that's the payoff structure. So now we've got two payoff streams. And this is the Honda's expected payoff of not cheating, of no cheat. So what can we do with these two equations? Set them equal to each other. So we got, that is our break-even point. Again, remember our logic is if the expected value of cheating is greater than the expected value of not cheating, then I'm going to cheat, or vice versa. So the interesting thing goes on when we set these two equal to each other. So if we set equation 1 equal to equation 2, we can solve for D that equates the two. All right, so this gets a little thick here. Let's just kind of write this out for once. Nope, Max. Oh, wow, it's late. Okay. Let's get this off our chest here and be done with it. I'm not going to give you something this hard on the test, so you can, but you need to know the logic because there'll be pieces of this that you need to know. So work through it with me, but I'm not going to make you do this on the test. I'll just tell you right now. All right, so if we factor out the D with the 20, it's possible to do 120 plus D times 20 squared. You know what? Let me do this later. This is going to take too long. We'll pick up there. We'll pick up there next time. The logic of it's more important, and then we'll cut to the chase. It's already almost 5:02, so. This is chapter 12. Yeah, Max here is. Yep. do it? Good. Oh,
Sorry, I was.
okay.
I don't know how to save those from school before.
That's fine, yeah.
It's a long homework.
Did you do the,
Just, there's like
The
5
four
problems,
problems?
or 4 problems that
Four,
you
okay.
assigned, right?
yeah, that's right. Yep, it was a longer one. We worked through, the only thing we kinda had questions on was the Stackelberg at the end.
Okay. So you guys finished 11.